The fundamental challenge is the same it's always been. Brands need to put ads in front of the right audience at the right time. CTV advertising has made addressable audience targeting on TV a reality, but where the current technology runs into challenges is when you attempt to scale up your performance. Supply and demand platforms are in a state of perpetual tension as both attempt to mitigate the costs associated with operating a programmatic marketplace. And every ad opportunity that fails to receive a bid from an advertiser is a wasted transaction for both parties. To mitigate costs, the supply side will attempt to guess at what the demand side wants and adjust their traffic sent in the future. The demand side will only bid on worthwhile opportunities, but the mix of advertiser demand is constantly evolving with new advertisers and strategies. We respect the designs that brought us to where we are today, but we think it's inefficient and a hindrance to true CTV performance. To solve this issue, we built the supply-side optimization agent. The supply-side optimization agent is a custom piece of tvScientific technology. We provide that to a supply-side platform, and they embed it in the RTB pipeline. Using an agentic interface, that technology then assists the supply-side platform by identifying which of those bid requests that are flowing through their system are of high value to tvScientific. The SSP can then take those signals and apply that to traffic shaping that is sent to our platform. To better illustrate this concept, you might think of the agent as if it were a personal shopper that's scouring the shopping world, looking for products that might match your preferences. And you ultimately retain final purchasing decisions, but by reducing the scope of options that you're evaluating, you can decide faster and evaluate more categories than you could have in the same amount of time. Someone might ask, isn't this a supply side issue? Why would tvScientific take on this work? What's in it for you? To those, I'd say that it is our responsibility to the marketplace to apply optimization strategies that affect the entire ecosystem. The theory here is that as we optimize, costs will go down, and as a result, advertiser performance will naturally improve. And that is the ultimate goal for tvScientific. That said, aside from performance gains that come strictly from cost reductions, the main advantage is that by tagging our preferred supply within this SSP, we see an improvement in the quality that arrives to our platform. That improvement directly affects our supply side and advertiser metrics. For example, after we turned on the supply side optimization agent, we saw the following impact. Advertiser cost per conversion performance metrics improved 50 to 70%. And participating supply side partners saw a doubling of bid rate on some deals. In the end, we're improving the performance for everyone involved in the exchange.
One of the big costs in running a digital ad auction is just transfer of data. There are thousands, tens of thousands, if you go all the way out to, display and search, we're talking about millions of requests for bid happening every second. And just sending that data over the wire is very expensive. Even if you're running in the same exact tight AWS region, just the cost of transferring data between two servers who are sitting next to each other in the same data center is high. Because there's no data going out over the wire, that means that we can see all the traffic. And instead of having, a stream of traffic for us to sort of pick through and try to identify the best components of, we can just go directly to the best stuff that we are more likely to buy. And that's good for both parties, right? If we're more likely to buy that traffic, then it is way more efficient for the supply side to send us that traffic. And so everybody wins, right? We get a much wider view of the aperture of all the traffic available to us, and the supply side partner gets a higher fill rate for the auctions they actually end up sending us, which end up costing them money. The main challenges with deploying the Shaper infrastructure is that we don't control the deployment ourselves, versus this is in many ways like the 2020s version of running a box on premises, right? We get limited telemetry. We don't have a lot of control about what types of instances we're deployed on, which is something that we control very tightly when we're running our bidder, even though the bidder and the shaper are based off of the same core technology. So because it's not transparent to us how the shaper is running, it's running inside of OpenX's infrastructure in a way that's efficient for them. It is a lot more difficult. You have to make a lot more predictions and have to have your software understand a lot more about the hardware that it is running on, knowing that the hardware that it's running on could change essentially at any time. So that means that you have to be really careful with memory. You have to be really careful with the number of threads that you're allowing your program to use, because you could be running on a big box one moment, and then the next you could be shifted over to a small box.